Hello, geometry students. We are picking up with section 6.4, rhombuses, rectangles, and squares. And I would like you to, if you have not already done so, make sure that you have your textbook with you and that you have your textbook open to page 347. All right, what we're going to do now is we're going to learn a little bit about you guessed it, rhombuses, rectangles, and squares. All right, so um, right here, this is from your book. Look up here where my little pointer is, and you can see what a rhombus is. I don't know if you've heard of that term before, but a rhombus is a quadrilateral or a parallelogram, more specifically, that has four congruent sides. You notice it looks like a slanty square. Um, so all the sides are congruent, but that doesn't mean that the angles are. Okay, so that's what a rhombus is. A rectangle, let's look at this middle one. A rectangle is a parallelogram with four right angles. So again, with a rectangle, it's possible that it could be a square, but most of the time it's not. It's got two opposite sides are congruent, and then two sets of opposite sides that are congruent. But the root of the word rectangle, here, let me make sure my pencil's on. Rectangle. This root of the word is a root for the word right, and then angle. Okay, so that's where it gets its name. And it's got four right angles, all 90 degrees, right? And they all add up to 360. All right, a square is a four-sided figure where you have four congruent sides and four right angles. Okay, so it's a parallelogram with four congruent sides and four right angles. Okay, so what's a rhombus? A rhombus has four congruent sides. A rectangle has four 90-degree angles, right angles, and a square kind of possesses both of these features. Four congruent sides, four right angles. All right, now the next thing I want to show you, here, let me clear this board. I am going to bring in another picture, which I think is pretty interesting, that sort of shows a sort of a Venn diagram of the relationship here of parallelograms. Okay, all right, so hopefully you can see this. And let me move it here. I'll just stretch it out just a little bit, a wee bit. Okay, all right. So notice this is a Venn diagram, okay? So what's a Venn diagram? Well, Venn diagram is one of these ones where, you can show the relationship between sets and stuff like that, in this way with circles. And if something is inside two circles, well, that means it belongs to both sets. Well, let's first look at the high level grouping here. At a high level, you have parallelograms. Well, what's the definition of parallelogram? At a minimum, you just need to have two pairs of opposite sides, right, that are parallel to one another. Underneath this breakdown, it breaks down into rhombuses, squares, and rectangles. Okay. Notice that rhombuses are all four-sided figures. Notice that squares appear in the set of rhombuses. And then here's rectangles. This can be any four-sided figure parallelogram that has 90-degree angles, okay? Notice that square also falls in the rectangle group. So this is a point of intersection. Squares are both a rhombus and a rectangle, okay? A square is a very specific form of rectangle or rhombus, depending on how you're looking at the definition. All right, so let's take a look at example 1. All right, and it says, and I want you to cover up the solution on example 1. It says, decide whether the statement is always, sometimes, or never true. It says, a rhombus is a rectangle. Is that ever going to be true? Sometimes, always, sometimes, or, what was it? It's always, sometimes, or never. Okay, is that true? Well, let's take a look at this. Think about the square, right? The square is a rhombus, right? And also a rectangle. So sometimes a rhombus is going to be a rectangle when it's in the form of a square, right? So that would be a sometimes on A. All right, now let's take a look at B. It says a parallelogram is a rectangle. Well, is that always, sometimes, or never true? Well, a parallelogram could be one of these slanty rhombuses, right? Or it could be, yeah, I mean, it could be one of these slanty rhombuses. And so in this case, it wouldn't be a rectangle. So this is also sometimes true because some parallelograms are rectangles. Um, so sometimes that could be a true statement. It's not going to be true for all of the different things because you can have, So anyway, I hope that makes sense. All right, let's move on to example 2. All right, and let me clear the board here for this. All right, in example 2, it says we have a rectangle. Okay, and forgive my rectangle here. It's not the best where I can draw here, but better than nothing. Okay, all right, so we got a rectangle, and here I'm going to put my little 90-degree marks here so that we know for sure that we're dealing with a rectangle. It says, what else do you know about ABCD? The quadrilateral ABCD parallelogram. Okay, well, if it's a rectangle, you know that it's a parallelogram, right? So you know that these opposite sides here, AD is going to be parallel to BC, and you know that AB is going to be parallel to DC. Okay, so you know that the opposite sides are going to be parallel. You know the opposite sides are going to be congruent. You know that these consecutive interior angles, right, are supplementary. Of course, they're both 90-degree angles, but they're supplementary. 90 plus 90 is 180, and again, A is supplementary with B. Okay, and so they are going to be, so that's still going to be true. Now, let's think about the diagonals. What do we know about, since a rectangle is a parallelogram, what do we know about the diagonals? Well, the diagonals, this is terrible, but this drawing, but the diagonals do bisect each other. So this is going to be equal to that, and this is going to be equal to that. And in fact, what we're going to find out, although the book is not saying this yet, you're going to find out that the diagonals of a rectangle are in fact even congruent to one another. Okay, because because you don't have the slantiness going on like with the parallelogram, like this, where you could end up with one diagonal like this one would be longer than this one, for instance. Here in a rectangle, you're going to have the diagonals be congruent to one another. All right, so let's take a look on page 348, and I want you to look at the top that's right above the green box. It says a rectangle is defined as a parallelogram with 4 right angles. But any quadrilateral with 4 right angles is a rectangle because any quadrilateral with 4 right angles is a parallelogram. And then it says, of course, in the exercises, we'll justify the following corollaries. So let's look at these corollaries. And I will come back on the next video for that.